Hi all, in this video I'm going to show you the last part of deformation of solids and is about strain energy. When a wire is stretched by a load of force, work is done on the wire and strain or elastic potential energy is stored within. Consider the force extension graph of this wire until the proportionality limit or Hooke's law has shown in figure 11.5. Hooke's law here is about force is directly proportional to its extension provided it does not exceed the elastic limit. This is about Hooke's law. And from figure 11.5, for graph force against extension, the total work done here is equals to strain energy, and it is about the shaded area. Once we know that the area below the graph is the strain energy, so we can find the strain energy by finding the area of this triangle. The area of this triangle is half times the force times the extension, and is about the strain energy U equals to half times force times the extension. And we have another option to find the strain energy by eliminating the force and extension, where force here equals to stress times area and the extension here equals to strain times the original length. Once we substitute these two equations into this formula, then the strain energy now is about in this form, with a combination of stress, strain and volume. Area times the original length, you will get volume. And now strain energy U per volume equals to half times stress times strain. Simple like a bubble without giving you any trouble. Hi all, let us try to attempt A level question. It's about a wire of length 2.0 meter and cross sectional area 1.0 times 10 to power of -6 meter square is extended 1.0 millimeter by a force 100 Newton within the elastic limit. Calculate A. strain, B. Young's modulus, C. energy stored in the wire. For A, strain is about extension per unit original length. The extension here is 1 millimeter and the original length is 2 meter. So convert to meter. 1.0 times 10 to power -3 meter divided by 2 meter, you will get 5.0 times 10 to power -4. It is dimensionless. Strain is dimensionless without unit. And for Young modulus, it's about ratio of stress and strain. You will get this formula and substitute all the values accordingly into this formula, and we will get Young modulus is about 2.0 times 10 to power of 11 Newton per meter square. C is the energy stored in the wire. For energy store, you can use this formula. Energy store is half times F times E. F is force, E is the extension, or we call it strain energy. Given force is 100 Newton and the extension is 1 millimeter. 1 millimeter, when you convert to meter, it is become 1.0 times 10 to power -3 meter, and the strain energy now is 0.05 joule. Or we have another option. By eliminating force and extension, where force here is equals to stress times area and the extension here is equals to strain times the original length. We can substitute these two equations into this formula and the formula will be in this form. And substitute all the values accordingly in this formula, and you will get the energy store or strain energy is equals to 0.05 joule. Simple like a bubble without giving you any trouble. And you can see it is similar. Thank you for watching this video. Thanks a lot, and thank you to the Lord.